In this ANSYS tutorial video, we will be looking at Lab 4 question number 2. Before we get started, we first have to determine which units we're going to use during this question. Looking at the example, the SI column of the chart is probably our best option. So we're just going to go ahead and convert all of the millimeter values here to meters and all the gigapascals to pascals. Next, we can go ahead and determine which type of element we're going to use during this question. Looking at this example, it appears that this thing is perfectly symmetric about the y-axis as it is a tube surrounded by concrete. Therefore, we can model just this right portion of it as a 2D object and specify that it's axis symmetric, so that ANSYS will rotate around the axis for us. Therefore, the element type we're using is going to be a solid with the axis symmetric element attribute defined. In terms of material properties, we have two sets of data given to us, one for aluminum and one for concrete. We're going to set ID number 1 to be our aluminum properties and ID number 2 to be all of our concrete values. Next, to create our 2D model, we are going to first create a rectangle here, then create two more rectangles that will later be our concrete. We are then going to add these two to create one big area, and we're going to glue these two areas together to give us our 2D plane of our axis symmetric model. Next, we are going to, under the meshing tab, we're going to have to specify which material ID belongs to which area, noting that this one right here will be aluminum and this one right here will be concrete. Next, in terms of constraints, we are going to apply align constraints to these two outer edges. Keep in mind that it's up to the user where they want to apply the constraints. In this example, I'll be applying a line constraint here and here with 0 degrees of freedom. But depending on your model, it is up to you. Also, I want you guys to note that these measurements here are arbitrary. I picked them just because I felt that at that distance the model wouldn't change, but once again is up to you guys to figure out where you want your concrete to end in this example, and just make sure you specify it in your work. So going down to loads, the only load that is being applied is a temperature change of positive 20 degrees, so we'll have to specify our reference temperature and our uniform temperature to change by positive 20. Going ahead, we're going to open up ANSYS, and first we're going to specify our element type as axis symmetric solid. So on the preprocessor, we're going to open up element type, and we are just going to select on solid 8 node, and under options we're going to make sure that K3 element behavior is selected as axis symmetric. Click OK, and we can go ahead and close that down. Next, we're going to specify our two sets of material properties. Under material models, we're going to specify our aluminum. So we're going to enter in 69 gigapascals and Poisson's ratio of 0.33. And under thermal expansion, we're going to enter in our thermal expansion coefficient. All right, now we can go ahead and enter in our concrete values. So under material, we're going to select new model, make sure that ID is set to 2, and we're going to repeat this process same as before, just entering in the new values this time. Okay, we can go ahead and close that down. Next, we are going to create our model. So under the modeling tab, create areas rectangle by 2 corners, and I wrote down the first set of points here. Alright, so your model should look something like this. Note that it may appear a little bit different depending on how deep you made your concrete and how long you made the slab. So we're going to go ahead and add these two areas up now to create our concrete portion of our model. So under the Operate tab here, we're going to click on Boolean, Add Areas, and just go ahead and select those two areas. Next, we can go ahead and glue these two portions together because they are going to be moving together in our model. So under Boolean again, we're going to select on the glue tab, areas, and select the two. We can go ahead and mesh our object now. So under meshing, mesh tools, we're going to set our area, and we're going to select on the concrete slab first, click OK. And we know that we gave the concrete slab material ID of 2. So under the material number, we're going to make sure that 2 is selected. Click OK. And now this area here should have all the properties of the concrete. We're going to repeat this process once again, this time for the upper area, and we're going to make sure that ID number 1 is selected to specify the aluminum part. Click OK. Now we can go ahead and set our size controls. So selecting both areas, we're going to set it to a value of 0.004. This is a number that I picked for this model, but once again, it is up to you. And we can go ahead and mesh our model. All right, so we can go ahead and apply our constraints rather. We are going to close down preprocessor, open up solutions, define loads, apply structural displacement on lines, and we are just going to select this outer two lines here and the bottom line here. Click OK. And I chose to make this an all degrees of freedom equal to 0. So I'm going to select all degrees of freedom and set it to 0. Click OK. And we should get something that looks like this on the screen. Next, we're going to go ahead and apply our load, which in this case is a thermal change. So under settings, we're going to select and specify our uniform temperature, which is our final temperature. So we're going to set that to 20. And we're going to specify our reference temperature, which we'll set to 0. So we can go ahead and solve our model. All right, so the question asks us to show all the body constraints. So to do that, under plot controls, I'm going to go down to symbols and make sure that all applied BCs is selected. Click OK. And these boundary condition arrows should appear on your screen if they hadn't already. Next, B asks us to show the stress distribution of the temperature increase. So to do that, under General Post-Proc, we're going to select on Plot Results, and we're going to select on Deformed Shape, and make sure Deformed plus Undeformed is selected. Click OK, and that'll give us our deformed shape. If we want to show the color distribution of where the stress is, we're going to go under Plot Contour Plot right here, select Nodal Solution, and we're going to make sure that stress is selected. Scroll down and make sure that von Mises is selected. Click OK. And here we'll get our color contour plot of our model with the legend here in the bottom.